I'm Nolan Westrope, and welcome to another episode of Gen Z in Manufacturing, a podcast where I interview young people about their journeys in the manufacturing industry. For this episode, I welcome Nolan Westrope, a 21-year-old mechanical engineering student at the University of Texas at Dallas. Westrope was introduced to the manufacturing process when he was a child helping his father work on a 1971 Chevelle Supersport. By the time he was 15, Westrope was tearing apart two broken-down Chevys in an attempt to assemble his own truck, which he completed at 17. Prior to college, Westrope's education included architecture and TIG welding courses at his high school's career center. In addition to pursuing a degree, Westrope is also the manufacturing lead for UT Dallas Formula SAE team, Dallas Formula Racing. Before we hear from Westrope, please make sure to like and share this episode of Gen Z in Manufacturing. To watch or listen to previous episodes, go to manufacturing.net and click on the Gen Z tab. If you are a member of Gen Z and would like to discuss your experience in the manufacturing industry, please get in touch with me, Nolan Westrope, at nolan@ien.com. Before we get started, we would like to thank our sponsor, RedZone. Empower your front line while growing your bottom line. QAD RedZone is the #1 connected workforce solution for plants of all sizes. It's time for manufacturers to start engaging their frontline employees, resulting in reduced turnover and increased productivity. RedZone enables you to stop analyzing yesterday and start solving today's problems now. For the first time ever, production, maintenance, and quality teams are following the same playbook. Well, Nolan, thank you for joining Gen Z in Manufacturing. My first question for you was, when did your interest in manufacturing and engineering begin?
My interest in manufacturing started pretty early on. When I was a kid, my dad worked on his old cars, his classic Chevelles and stuff like that with me, and I was kind of sit there on the stepstone when I was like 4 or 5 and hand him wrenches, and that kind of started my interest in engineering as a whole, and that kind of grew and snowballed as I got older. I took architecture classes in high school, started learning computer-aided design. Took welding, and that's really when my manufacturing side of things kicked off. I took a welding class and became certified in TIG. And then coming into UT Dallas as a mechanical engineering student, I got involved with Dallas Formula Racing. And then because I know how to weld, I started working in the machine shop. Now I'm a student worker in the machine shop and also the manufacturing lead, but it's really more fabrication lead for Dallas Formula Racing.
When you were in high school before starting college, how did your high school support students who are interested in the kind of fields you've been talking about?
My high school actually did a great job with it. The school district I was part of, LASD, Louisville Independent School District, had what's called the Career Center. They had a Career Center East and West, and the East one focused on lots of technical skills, architecture. You could get like certifications in nursing, like all sorts of little things, bioengineering. They had some classes in that. And then they started adding on more physical hands-on things. They had a wood shop there. You could get carpentry skills in, and then they added a welding shop. So my high school actually really helped my interest in manufacturing and engineering and fostered that growth by offering another campus, a whole extra campus full of these opportunities that I could pursue and get certified in.
And how does UT Dallas support the students who are interested in the manufacturing industry and prepare them to enter the workforce when they graduate?
Well, that's a bit of a tougher question to answer in a good light. UT Dallas doesn't do a whole lot, honestly. We're a pretty new undergraduate school. It was only became access to undergrads in, I think, the 90s. It was a graduate school before that, and we only just got a machine shop to begin with. But that's not for students. We don't really have any good maker spaces on campus. As a member of Dallas Formula Racing, this is one of the things we've been pushing for, is getting our own space to weld in. Like today, before we came here, I've been welding for about 5 hours straight. In the machine shop, I have to go to the other side of campus from where our lab is to go focus on actually learning this, going from an idea to a prototype. I have to do that all on my own. Dallas Formula Racing does a great job teaching people, not to pat myself on the back here, but I'm the one who does it. So on that process, but UT Dallas, I know it's on their radar eventually to get to, but right now they're not doing a very good job preparing students for the workforce for manufacturing.
So, I mean, I know you're only a junior in undergrad, but just kind of how would you encourage universities to better prepare students for going into the workforce, especially those that are interested in manufacturing?
Definitely let students get hands-on experience. I know UT Austin, I got a chance to tour their machine shop. about a year ago, and they actually have a required course for mechanical engineering students to go through the machine shop for one semester and learn how to use all the machines. Understand the process that tools exist, like not just in the like, oh yeah, a plier's a thing, but like an end mill has to be able to reach your part in order to cut out what you need in manufacturing. You can't design something that's impossible to make. And that's something that I think a lot of students have struggled with. And I think that's something that universities should hit a bit harder, actually make the parts that you design. Obviously, manufacturing gets into a whole broader scope than just one-off prototypes. And I think that's something that's much harder to teach in an undergraduate degree because so much of the undergraduate degree is focused on the design analysis side of things than the turn it into a real viable product. But maybe master degrees or something like that is a better place to focus on that side of actual how do injection molds work, what's the efficiency on that, when do you use sand casting, that sort of thing.
Do you have any connections to people that have already gotten jobs in manufacturing?
Specifically for manufacturing, I don't believe so. I have a lot of friends through Dallas Formula Racing who have gone on to join lots of different automotive industries. I have friends at Toyota, Peterbilt, Tesla, but not that I know of directly in the manufacturing space.
So those professionals, what are you hearing from them about what they're liking about their job and how they feel treated at their place of work?
It depends pretty greatly on who I'm talking to and what they're doing. A lot of them, Dallas Formula Racing fosters kind of a startup mindset, and all these people come from Dallas Formula Racing. And with that mindset, like Tesla, if you get on a project that lets you do overtime, a lot of us spend 70, 75 hours a week, like grinding out, getting that overtime pay, solving our problems. And we love that. Like that's how we work. But I know a lot of people get on projects where they're not allowed to do that, and they kind of suffer a bit more where they're put in a box and said, no, you're not allowed to work more than this because we want to, explode out and pursue our ideas.
How did you get into Dallas Formula Racing?
Well, it was kind of a funny story. They had crashed the car when I was a freshman. Completely like took one of our tubes, space frame chassis, and just bent it straight in. And we had to cut that out, order a new tube. And I just kind of walked up as a freshman at one of the, I think it was a powertrain meeting, talking about, the engine and everything like that. And said, yeah, by the way, I'm certified in TIG welding. And his eyes just like lit up because that's not something you get very often in mechanical engineers, actually having real world hands-on experience with this fabrication process, especially as a freshman. And immediately he pulled me aside and said, you're going to get machine shop certified because they have a whole certification process to go into the machine shop for safety and everything. And then we're going to put you in there. We're going to weld this chassis because we need this thing fixed. So I kind of thrown into the deep end, like in November of my freshman year, not even been on campus for 3 months yet. And I was sitting there welding on this depends on which car, but $50,000 to $80,000 car that we've designed and manufactured in-house. And I just kind of excelled from there.
How have you applied all the education you've collected up to this point in this project?
When I went to the Career Center, more so, actually. Being able to weld has been crucial for this project. That's not really on the engineering side of things. It's more on the fabricating side. But as for the engineering things, I can't really tell you. CAD skills, I've had to take some classes where I have to do computer-aided design, and having access to that on campus on these machines that we have in the computer labs and stuff like that, that's been a great help, being able to design my parts there. But as far as analysis is concerned, all my FEA skills that I've learned have been through Dallas Formula Racing. Any CFDs that I've conducted have been through Dallas Formula Racing. Programs like ANSYS, NX, we don't learn those here on campus. We have to do that manually as part of our curriculum as Dallas Formula Racing. I actually had to make my own curriculum for welding because it's not something the school offers. and to teach other students how to weld, how to get involved in the manufacturing process, independent of the school.
As you've worked with people your own age, what have you learned about Gen Z's work ethic, and then what characteristics should employers expect when they hire Gen Z people?
I'd say that they should expect a whole range of personalities. With the internet and how it's facilitated our communication, we're allowed to find people who are like us, even if we have such a weird niche personality. We've been able to foster a group of people no matter how different you are. And being able to find those people means you don't want to change yourself. You already found your people. So expecting not a homogenous personality type that you find, like with older generations, Gen X, boomers, all that sort of thing, they all had the same world they were growing up in. Gen Z doesn't. We all have our own echo chambers we find ourselves in. If you find someone from Dallas Formula Racing, they're going to have a completely different personality and skill set from one of the comp sci majors at Nebula Labs, another one of the student orgs here on campus. And it's just one of those things that you have to understand, I think, as an employer, that we're not all going to fit in the same box.
What opportunities has the racing team exposed you to?
I've had people who have had connections at Tesla directly talk to their recruiters about me. Same thing with NASA. I'm reaching out to some of my friends who work at other smaller organizations nearby. Like we have a Corvo is area right next to me, TI, Texas Instruments. And, like I said earlier, I've had friends talk to me about Peterbilt's, other little startups. There's all sorts of connections. I honestly could not name all of them. That I'm wearing right here. Sorry, I've been wearing a welding hood all day. I got to go see, I don't know if you can read that, Aston Martin. I got an opportunity to go see the paddock at a Formula One race and get free Formula One tickets at Austin, at COTA, through this team. They gave me this free $60 hat. And it's like, I never would have done that if it wasn't for this team. I got to actually be about this far away from a Formula One car. And that's just like the most amazing experience you can ask for a mechanical engineering student. While they were disassembling it, I got to see all the parts. Like the super top secret stuff they don't let anyone else see. I'm looking at the floor of a Formula One car. It's crazy.
And through all these exposures, has it altered how you view a professional workspace or changed what you want to do when you graduate college?
It's shown me that I'm more capable than I thought that I was. That I don't have to necessarily subscribe to being a CAD monkey for the first 5 years of my engineering experience. A CAD monkey, I don't know if you're familiar. Computer-aided design monkey, someone who sits there and goes through the numbers, draws the diagrams, makes the drawings. I can actually offer good qualitative skills to employers that I'm worth more to them than I originally had thought, even if they don't necessarily see it that way yet. People are accelerated nowadays compared to how they used to be. When you see a 21-year-old when you're 60, you think, oh, look at that kid. But we're, of course, still immature kids. Don't get me wrong. Don't ask me what I did last Friday night, but that's aside the point. We still have a lot of skills to offer that I think they assume are only going to be found in more senior engineers. I think it's going to take a very long time for those people higher up to understand that and to actually make a change at the end. I don't know if it means we're going to need some people to retire, or we need younger people in CEO positions, or at least hiring manager positions, or if whoever tells the hiring manager what qualities to look for, that needs to shift. I think it's going to be a while, from my perspective at least, until everyone understands that.
What kind of job are you looking for once you enter the workforce?
The one that signs my checks mostly. Uh, I want something that allows me to explore my creativity. I've been talking to some companies in manufacturing about working on a like factory floor, designing the both the prototypes and then how we're going to produce those prototypes for various different technologies. One fiber optic company was talking to me about how they need help integrating from their design to their customer. And right there in that, design the test benches, design the production capabilities. I think that's where I'm going to try and find my sweet spot.
How can employers fill those traditional manufacturing jobs on the floor with the new workforce?
That's quite the question. That's the question, I think, isn't it? Huh? Like that's what everyone's trying to figure out. I think appealing to us. We all think we should get the glamorous jobs, the person designing the engine of the new Toyota, whatever. Um, that we need to do the aero research for the new fighter jets, or that we need to go out and save the world. Um, and I think that's just kind of the cultural mindset that Gen Z has. We need to find a way to express how critical these roles are to reaching those end goals. And I think that General Motors does something called like flex positioning for their interns, where they'll take 8 weeks and go spend a week in each of the different fields at the facility. And then at the end of that, you figure out where you're going to spend the rest of your time. I think that's a great way to show Gen Z what there is out there, how all these systems interconnect, how everything is critical, how there isn't a less glamorous and more glamorous job, that all of them are required to bring this product to life.
Thank you for watching this episode of Gen Z in Manufacturing. Please make sure to like and share the episode. To watch or listen to previous episodes, go to manufacturing.net and click on the Gen Z tab. If you are a member of Gen Z and would like to discuss your experience in the manufacturing industry, please contact Nolan Beilstein at nolan@ian.com.